Hey there, everyone. My name is Ryan Schul. Welcome to my data science channel. So in the topic today, I think this is very, very interesting. I want to talk about how to predict which NBA team will win when they face off in the next game that they're going to play. Okay, so whether you're a fan or not, data science is one way to get more insights into sports analytics and understand sports management and predicting certain outcomes, right? What's going to happen at the end of this game and which team is going to win. So this is interesting from many different levels: betting and fantasy sports, team strategy and coaching, front office decision making, fan engagement and broadcast, risk assessment and lead management, as well as just understanding some of the key tenets and key principles of data science and machine learning practice, right? And how to implement this in a real world scenario. That's exactly what we're going to do, okay? And real world gives us real value. This is basically prediction plus insights, right, to make these types of decisions. So that's what we're going to look at. Let's get into it. So I'm going to share all this code with you. It gets a little bit complicated, but it's not too bad. Just stick with me. You don't have to make notes and understand all the nuances and all the details of every single line of all these scripts, right? I'm going to share this with you in HTML format, so you can download this, copy and paste it into a Jupyter notebook and run it for yourself, or just view it in the HTML file and understand what's going on from that perspective. Okay, so we're going to import a couple of libraries that we're going to use below. This is pretty common. We always do this for everything, right? So Python has, at this point, probably over 10,000 libraries. Let me Google this. I'm a little bit curious. Google, okay. How many Python libraries? There. Okay, it's the first one. Nice. Whoa, is way off. Oh my goodness. 137,000. Jeez. That's kind of shocking. I had no idea. 137,000 libraries. Okay. I thought it was 10,000. I was way off. But anyways, the point is, like, we import these libraries at the beginning so we can use all these scripts that, or so we can use all these lines of code that show up in the script down below, okay? So I'm going to create a list here and append everything to the list. You can see the name is all teams log. Control F is right here, and here's the append, okay? And I'm also going to convert this into a data frame and append all of these items that I'm getting from calls that I'm making to an endpoint, okay? And this is going to be all the NBA teams, and the data basically is stored in JSON format. We go fetch it as JSON and convert it into a data frame so it's easy for a person to read and append everything right here. Okay, so that's what that is doing. And when we are all done, we can go ahead and view the data frame set. So where is this data coming from? Basically, it comes from right here, okay? And I did a little research on this. So the NBA has several API endpoints where they store and load all of the team's data. So for every team, they'll have, okay, who won, who lost, basic information like this, right? And some of the conditions of the players. They don't have all the players' stats and all the details of all the players. Okay, when I run this, I get, what is this thing now? Let me take a quick look. Let me actually see how much is collected here. Sorry, should have done this before. I didn't even think about it. Print. Oh, I want the shape. Okay. Oh, I don't need that. Sorry. Why stick with it? Okay, so we have 2,460 rows in this whole data frame, and basically these are all the games that were played for the 30 NBA teams. Right now it is mid-May, or kind of the end of May 2025, and there's 30 NBA teams. That could change over time. There could be new teams added to the list, maybe some dropping out eventually. Who knows? But at this point in time, we have 30 different teams, and these are all the games that they play. So we have some details over here: team ID, matchup, who won, winning, lost, win percent, minimum, field goal average, 3-pointers, what is this over here? Rebounds, assists, steals, things like this, right? So this is the stats for the entire team. and then you have the team name over here. So that is essentially the data set that we're looking at. And I'm going to do some basic statistics on this data so I can train a machine learning model and try to make predictions into the future, which team is going to meet, and predict the probability of one team winning over the other based on historical events, right? What happened in the past is a pretty good indicator of what's going to happen into the future, but we're going to make all these predictions because you don't know for sure what the outcome is going to be, right? So with the team name, you saw that as the last column over here, okay? So I'm taking some new data that I just created. This is called feature engineering and appending it onto the same data frame. So I have points rolling average, that's points rolling average, assistance rolling average, and rebounds rolling average, okay? Then I have the win streak, and whether or not this is a home game or an away game. Sorry. So basically the concept here is if you're on a streak and you have several wins, you're more likely to have another win, right? And if you're playing at home, you're more likely to win the game. So a winning streak based on points rolling average, assists rolling average, and rebounds rolling average, and the win streak, and whether or not it's a home game, we can use this information to feed into a machine learning model. I'm going to use log regression because I want to predict the likelihood of a certain outcome. Okay, so this is actually a classifier. A log regression model is actually a classifier. I have an XGBoost classifier. So XGBoost is sort of an ensemble learning model where you take one action and then you boost it up to another level. You do an analysis and then you take the result of that, boost up to another level. You do the analysis again, take the result, boost that up to another level, right? So this works sequentially. It's a little bit different from a random forest type of classifier where random forest, everything works in parallel and you're looking at all these different branches and you go down to the leaf level. You start kind of at the trunk, right? And you go down to all these different leaves and look at every possible combination of every outcome and then make a prediction into the future and see how accurate that prediction is. Okay, so I'm actually looking at 3 different models: XGBoost, random forest, and this is a classifier, and then log regression. I have to look this up because I'm always confused. I know it's a classifier, but it sounds like a regressor because it's called log regression, but it's actually a classifier. Okay, so these are the 3 models we're using right here. You can see that, and I put that into a dictionary. When you see these curly braces, that's a dictionary. When you see the key value pair, this is the key over here. This is the value pair. So when they have a separator, that's a colon. That's a dictionary. It's a little bit different from that list object that we saw before. A list has square brackets, and you'll take all your data and then append it into a list, and then you can do a bunch of things. You can print the list, convert the list into a data frame, all kinds of stuff, right? So that's where we are. So now I'm going to create abbreviations. Again, I'm going to use a dictionary, and we have these key value pairs. I want to create abbreviations because that's how the data comes to us from this endpoint over here, right? This NBA endpoint I showed you initially. So all the value comes in a certain format. I'm going to just reformat that data and reconstruct it so it's a little bit easier to work with. So I have abbreviation to name because I want the full name. I think that's a little bit easier to work with. So Oklahoma City Thunder. So I know what that is. I didn't know OKC is the abbreviation. I knew this one. Utah Jazz. I know that. So some of these you can kind of figure out. Golden State Warriors, I think you can figure it out. But some of these, like that one, I wouldn't know. So I want to convert this to something that's just a little bit more consumable, a little bit more user-friendly. So so it's easier to interact with too, okay? So I think I just ran this. Did I get an output down here? Yes, okay. So I'm saying it ran. I'm doing the abbreviations, taking all these abbreviations, getting the actual name from that, and then I'm going to go ahead and do rolling averages over here, rolling assists, rolling rebounds, win streaks, points rolling, assists rolling, rebounds rolling, win streaks, and then whether or not it's a home game and whether or not it's a win, right? So these are the feature engineering exercises that we did over here above. I wanted to take all of that, feed that into the model, take all these teams' names, and then jam that into the model too. And then down here, I can start to make predictions. So here's the actual train test split. So you always have to train the model on a portion of the data, not the entire data set, right? You usually use 70 to 80%, could be 75%, could be a little more or less. Usually it's 70 or 80% for the training, and the testing is the holdout. So that's the remaining 30 or 20% that you didn't use to train the model, because if you use everything to train the model, it's simply going to memorize everything. Computers are very good at memorizing, right? But you don't want it to just memorize it, because you don't know if the model can make decent predictions on unseen data, right? So you want to test it in a simulated fashion. Okay, I'm going to give you 70 or 80%, hold out the rest of it, the other 20 or 30, and then I want you to make a prediction, and I want you to check your prediction against what that value actually was. That's the whole point of this whole experiment, right? So here we're using XGBoost classifier, and we have our results. So this looks pretty nice right here. So we have Boston Celtics and Atlanta Hawks. Okay, so I put together a couple lines of notes over here. So in the script, we're doing the following: loading the data set, grouping and averaging, looping through all team matches, building the matrix, and then displaying the results using pandas. Okay, so here's the final matrix. Here's all the teams facing off against each other over the course of time, because we have that historical data. And again, I want to make predictions and understand the probability of a certain outcome or a certain team winning the next game when these two teams match off against each other, right? Or match up against each other, whatever it is. So the row is always the home team, and the column is the away team. The value is the probability of the home team winning. So if the row is the home team, the row is going to be Atlanta Hawks. That's the home team. This is the away team, Boston Celtics. So when the Atlanta Hawks meet the Boston Celtics next time, the Hawks have a 91% chance of winning the game. Now, when the Atlanta Hawks meet Brooklyn Nets, they have a 14% chance of beating the Nets. Okay, when the Hawks face off against the Hornets, they have a 38% chance of beating the Hornets. Okay, that's how you have to interpret this. And I know it's a little bit confusing. I tried to come up with a few different ways. This ultimately made the most sense. It was the least confusing, but remember, it's always the team and the row that has the probability of winning. And I have that in my notes on here. So the row is the home team, column is the away team, and the value is probability of home team winning. So when the Washington Wizards face off against the Hawks, the Wizards have a 31% chance of winning that game. Okay, so I took this one more step and created a heat map down here so we can visualize what the outcome is for all these potential wins and losses. So Wizards, we just saw, was 31.729% chance of winning, right? And if we saw over here, the first two we looked at was the Hawks and the Celtics, Hawks and the Nets, and we have 91 and 14. And that's what we'll see down here. Put my mouse out, there's the 91, and that is the 14. And the way, again, remember, it's always the home team that's on the row, and it's the home team's probability of winning. So if the Hawks face off against Boston Celtics, they have a 91% chance of winning. Hawks versus the Nets, the Hawks have a 14% chance of winning. Okay, so that's how you interpret it. So I thought this was a pretty cool exercise. I'm not a sports gambler, so I know the statistics is solid. I know the machine learning and data science is very solid here. I don't really know that much about sports gambling or betting or anything like that, so I don't know how to cater to that. And I wouldn't say use this as the gospel truth and bet a ton of money. That's not my intention here. And if you do bet some money and lose, don't come after me. I don't have any money. I literally have been unemployed for 18 months. So that's why I'm creating these videos, to give me something to do during the day. But yeah, don't try to sue me. I don't have any money, right? It's a fun exercise, and you can test it. You can test the strategy, and you can see how it works if you are into sports betting or if you're into gambling or whatever. I think it's a very interesting exercise. I know the math, the stats, all the computer science, machine learning is tight. I don't know about sports betting, so I can't say, I can't speak to that. Okay. So we're simulating matchups in conclusion here, and the home team and the away team are plotted ultimately with the probabilities when these two teams face off against each other. The home game, one means the model interprets the row the home team as being at home. I explained that, and we're predicting the probability that the home team wins because the target variable, win equals 1, corresponds to the team that is being modeled. The home team in this example is the row team. Okay, so that's how you interpret it. So that's it. If you do have comments or questions or suggestions, put that in the comment section. And if you were into sports betting, I'd love to hear something about that. And give me your thoughts on that. And if you test this model and try to understand, how well it performs in the real world, that's great. I would encourage you to do that. But remember, there's always probabilities here, right? There's no guarantee. So here, the Hawks should be the Celtics, right, with a 91% chance of probability. But the Celtics could win, right? If a key player fouls out and doesn't even make it into the fourth quarter, then you have a big handicap right there. If a key player sprains an ankle or has a serious injury and they're out of the game, then it's going to be a potentially very different outcome, right? So during these games, anything can happen. I'm just showing you like historically what has happened in the past and then how to make predictions into the future. That's what this exercise is for. So hopefully that was informative and enlightening. I try to make these things very practical and very realistic, and it helps me to learn new things and to refine my skill set. All right. So that's why I put this stuff together. So that's it. I'm going to save this and I will share the file with you guys later today. Thanks for your time. And I'll see you guys soon in the next video for sure. Okay. Thanks. Bye.